Good afternoon, everybody. Welcome to another session of our telematics. And today we're going to concentrate or look at how we can do some cubic graphs that is in calculus. Right? We refer to there as a third degree graph. Now there are three types of questions that we're going to concentrate on today. Number one, how to sketch it. Number two, how to do the interpretation. And thirdly, what if they give you a derivative graph and you have to do interpretation from that? Well, special welcome. I see Arcadia, Peakview, New Orleans, Liam Delport, hy's ook ingeskakel. He's also, in here. Welcome to all of you guys. Please, what I would like you to have is to interact with me. I'm going to ask certain questions and would like you to send some answers. So from me, once again, a warm welcome, and let's hope we're going to have a wonderful session. Let's have a look at the PowerPoint presentation. What do we need to know about our cubic graphs in calculus? Short and sweet. When you have to sketch it, there are four things that you must know. Number one, identify the shape of your graph. Very vital, learners. You need to know what your graph should look like before you start doing your calculations. You need to determine the y-intercept. Secondly, thirdly, how to determine my x-intercepts. And then lastly, how to determine the turning points. So those are the information or the four steps you need to follow. Let's have a look at them individually very quickly. What about the shape? The shape says, if that is the equation, what if a is greater than 0? Now a, as you know, learners, is the value in front of, the numerical value in front of x to the power of 3. Right? That value over there. If that is positive, then we know the shape of the graph must look like that. You see, that is what I'm referring to, your shape. If it's less than 0, that means negative. That is what your graph should look like. Now guys, you need to work out something. How will I remember what the shape looks like? Well, you determine, right? Just as long as you know, if it's positive, my graph must look like that. If it's negative, it must look like that. Now, what about the y-intercept? I think that is probably the easiest of all. Y-intercept is your d value at the back. That means the numerical value, the number without x. And as you can see, good practice would be write your answers as ordered pairs. You see, so the y-intercept is 0, and whatever the d value is, you put it over there. What about our x-intercepts? That is the equation. Number one, it says, determine a factor. And by now, you know exactly what I mean. Find or substitute x equals 1 into the equation, minus 1, 2, minus 2, etc. until you get 0. That is what I mean, a factor. Then you use any other method. There's synthetic division, there's inspection, there's long division, there's even the calculator. Any method that's suitable for you. And then you determine your x-intercepts. Your end product is that you should have that your x-intercept is the one x value 0, x2 0, and x3. And you know, of course, there are times when two of this will be exactly the same. Because it's a third degree graph, we need to have 3 x values. What about our turning point? Quite work involved here. Number one, it says determine f prime x, or should I say f dash x of the equation. What does that mean? Find the derivative. If you find a derivative of a cubic equation, that derivative will be a quadratic equation. What does that mean again? Your answer will be x to the power of 2. And x to the power of 2 means you will have 2 x values. So to solve the quadratic equation, you should have 2 x values, right? x1 and x2. To get your corresponding y values, you will substitute x1 and x2 into the original equation, right? To get y, substitute x1 into the original equation and x2, and that will give you a corresponding y1 and y2, right? So that is a bit of work involved, and you have to be careful not to make a mistake. And then lastly, the concavity, or should I say, the point of inflection. How do we work out the point of inflection? And you will see, quite easy, we just need to understand how. So the point of inflection, if that is an equation again, it says, determine f prime x of the equation, right? We know that's a derivative. If we do that, we will get a quadratic equation. What we do, now we find or determine f double prime x. Again, what does it mean f double prime x? You will find the derivative of that derivative. Let's just have a look at it again. So that is the first derivative, right? F to the power of f dash x. That is the first derivative. You will get a quadratic equation. And if you find the second derivative, you will have a linear equation. What that means, you should be able to get one x value. Very important, guys, to solve x, make sure that you put f double prime x equals to 0 and you solve x. And that will give you the x coordinate of the point of inflection. And how will we get y? I will substitute the x value, that x over there, into the original equation. And that will give you your point of inflection. Okay, learners, a very brief description of what you need to know when you have to sketch a cubic graph. Also, thank you very much. We have a visitor, Deborah Asali Labaskachni. Well, I'm also looking forward to working with you. And then there's learners from Mutmem. All of you, welcome again. Please don't stop with your SMSs or your information so that we can work. Right, guys? Let's start with the sum. Let's have a look at the first sum here. This is in your booklet, but if you don't have it, it's fine. Let's have a look at this, and then we can see what do we need to know. It says there, given a function fx equals x to the power of 3 plus x to the power of 2 minus 5x plus 3. So they give you a function there. Can you see third degree? Now let's just have a look at the questions. And you have to work systematically. Once again, please guys, try to work with me. It's going to make it much faster and excited if you can send me answers. 1.1 says, show that x minus 1 is a factor of fx. Now, there are certain key words in sums that must tell you, I know what it means. If it says, show that that is a factor, it means, yes, if we substitute that numerical value in there, we must get 0. Can you see? It's obvious questions. We can just prove it. So at 1.1, we have the equation fx equals x cubed plus x squared minus 5x plus 3. What is my factor value? X minus 1 is the factor. So the factor value is, I take over minus 1, then it is 1. So what it says, wherever I see x, I'm going to substitute that with 1. So what it means, I will have 1 cubed plus 1 squared minus 5, that's also 1, and plus 3. And please make use of your calculator to assist you. It will make your life a bit easier, right? If we put that in the calculator, the answer is equal to 0. So what does that mean? Therefore, that x minus 1 is a factor. You see, these are easy marks if we just need to get the understanding. Okay? 1.2 asks us, factorize fx fully. Right? Factorize it fully. Let's have a look at what does that mean. Now, you also have to work very smart in this. To find x, let's put the equation, which is x to the power 3 plus x squared minus 5x plus 3, right? Let's put it equal to 0, all right? So what does that mean? We found already one factor. So we know x minus 1 is a factor. So what we know is that we will have a quadratic equation or expression over there. And we can already get the first and the last one, right? One way of doing it. X times x squared is x cubed. Let's just look at that pattern. The first and the first give you the first. You with me, guys? Now, the same thing with the last. The last and the last must give you the last over there. So, minus 1 times what gives you plus 3, and that is quite easy. We know it is minus 3. So, can you see? You already have 2 terms. You just need to find the middle one. And I will say it again. I see this already. Tariq them say, sir, we will use synthetic division. Great stuff, guys. Whether any method you use, just as long as you can get that one over there, right? So, one very quick way of doing it, we can just say x minus 1, we have x squared, we are looking for bx, and minus 3, right? So, that is what we're looking for. What is that one over there? And it's quite easy to work out that. You will just say that bx, right, squared, or should I say bx squared, or that one with this one must give you this one. Again, guys, I'm not saying you can use any method. If I multiply that, I get minus x squared. And what should my end product be? Look there, plus x squared. So can you see? So what is bx? It's easy to see as that bx is 2x squared minus x squared, and that is equal to the plus x squared. So what does that mean? Is that our factors would be x minus 1, x squared plus, so what is missing there? 2x, absolutely, right? Minus 3 is equal to 0. And if we factorize that, we will have x minus 1, factorize that trinomial, x minus 1, and x plus 3. I've seen a lot of sisa, zintli, bupeze, exo, yaneli, asali. Oh, guys, I can see you have a great understanding. Thank you for your contribution. Don't stop, right? Let's go back to our sum. So if they say factorize, that is what they mean to get the factors, right? They don't ask for the x values. If you continue, they won't penalize you. Now, 1.3, they ask you now, determine the x and the y intercepts. X and y intercepts. That should be quite easy. Why? Because I already have my factors. Now, guys, again, your intercepts, write it as ordered pairs. So, what's my x-intercepts? You agree with me? It's 1 and 0. It's again 1 and 0 there. You can repeat it if you want to. And for that, it's going to be minus 3 and 0. Are you happy? And then lastly, my y-intercept will be 0 and minus 3. So can you see the information? It is there. It is just how do I go about in order to get that specific answer, right? All right, guys, let's just go back and just see what is our next question. Be careful when we get this information. This is what you are going to need in order, right, to get to my answers there. Right. Let's look at the next question. Determine the coordinates of the turning point. Turning point is a bit of work. Now let's look again. What is our turning point? 1.4. Remember, how do we get the turning point? What did the PowerPoint says? Find the derivative. Let's just write that again. F prime x. Remember, there's your equation. So what is the derivative of that? That by now, quite easy to you. It's 3x squared plus 2x minus 5. Happy? What is the next step? Very important. Right? Make a big star next to that. Make sure that you put the derivative equal to 0. Very important steps, matrix. Make sure that you always show that. Okay? We need to factorize that. Again, a trinomial. How we can factorize? 3x. We're going to have x, happy. We need a plus 2. So it's going to be plus 5 and minus 1. That is equal to 0. And therefore, our x values. 3x plus 5 is equal to 0, or x minus 1 is equal to 0. So what are my x values? 3x is minus 5. So x is minus 5 over 3, or x is equal to 1. Remember, that's the first part. Now the second part, guys, just be careful. It's also a lot of work. That is x1, that is x2. To get y1, we need to substitute that minus 5 over 3 into the original equation. Why? You can do that quickly. Wherever I see x there, substitute minus 5 over 3. That is for y1. Right? Let me just give you an idea. This is what you're going to do. Minus 5 over 3 to the power of 3. Minus 5 over 3 squared minus 5 times minus 5 over 3 plus 3. Quite a daunting sum, right? And for my y2 value, that is something that's not new. Why do I say that? Because when we substitute 1 in there, what was our corresponding y value? It was 0. Right, guys? I'm still waiting for that answer. Okay? Now, going to be a fraction. Okay, I see some of us, maybe you're still busy. Let me just assist you because the time might be a problem. You should get an answer of 256 over 27. Yeah, looks quite ugly. And if you want to make it easier, we can write that it will be 9,5. Right? So now we have our turning point. For x minus 5 over 3, remember if we substitute in there, our corresponding y value is 9,5. Happy? And then for x equals to 1, my corresponding y value is equal to 0. So be a bit careful. You can see it's a bit of a challenge, but if you have your calculator, it can assist you. Right? Let's have a look at the next question. It says there, 1.5, find the x-coordinate of the point of inflection. Remember, what is the point of inflection again? It's a double prime. So f prime x equals 3x squared plus 2x minus 5. Agree with me? That is what we've worked out when we worked out the turning point. Now remember, the point of inflection is f double prime x. That says I must find the derivative of the first derivative. So the derivative of that again, it's 2 times 3, that is 6x, and that is plus 2. Again, make that in your notes. Put the derivative equal to 0. It's quite important, guys, so that you don't miss out on unnecessary losing marks. Right? So in order to get x, we take over plus 2, it becomes minus 2, divide both sides, by 6. So x is therefore equal to a third. Right? And that is what they ask. They ask only for the x-coordinate. If they want the y-coordinate, remember, how do you work that? You will substitute this value, right, your x-coordinate of your point of inflection, into the original equation. Happy? Now 1.6 it says, now draw a sketch graph of fx. Now this becomes a challenge with a lot of our learners. We work out the stuff, that is what it is. We can work out everything. But now, how can we put this on the Cartesian plane? This is our challenge. And let me just give you an idea. Right, let's start here. Our x values, we said there, it's plus 1 and 0. You agree with me? Our other x value is minus 3. Right? And 0. Right? Then we have to work out our y-intercept. Oh, I'm glad. I see somebody told me, yes, sir, how did you get the y? Emma and Amina, thank you very much. Yes, a slight mistake. I mean, I'm glad that you are giving me a reminder about that. Thanks for that. I appreciate it, guys. Let's just have a look at this here, y-intercept, guys. Right? The y-intercept, we said, is the numerical value at the end. Right? The numerical value. And that numerical value is the value without x. And if you look at that, it should be plus 3. Thanks again to Emma and Amina for just showing that to us. Now let's just plot the y-intercept at 0 and 3. Okay, there we have it, at 0 and 3. Then the next step is our turning point. Our turning point is 1 and 0. Happy? Is that point over there. And then minus 5 over 3 and 9.5. So sometimes it's advisable. Remember, it's not a perfect sketch. That we can also say is about minus 1,7. Again, guys, not a perfect. Just make sure that you understand where is minus 1,7. Right? That's minus 1. There's minus 2. So it's in between. Right? It is in between. So it's about there. And in 9.5, if you go up, you can see we have a point there that says that's going to be minus 1,7 and 9.5. Right? Now, this is sometimes the problem that we have. We have all the points, we plot them. The issue is, how do I join them? Now, just to give you an idea, we know the graph must look like that. Right? Why? Because A is positive. And this is what I normally ask the learners to do. You see, there's your one turning point. And you see, there's your other turning point. Right? So what I always tell the learners, can you see what I did over there? Circle your turning points. Now remember, this is the one turning point. And there's your other turning point. Because if you do that, then it gives you an idea where it must turn. Now look carefully. On the left-hand side, can you see it turned maximum? So if this is on the left-hand side, we know that must turn like that. Do you see what I'm getting at, grade 12? You see there? It turns like that, so that must also turn like that. And the one on this side, what we know, it turns like that. So that is just to give you an idea. Once you plot your points, circle your turning points so that you can see, okay, I know it must turn there and I know it must turn there. So what I do from there, I just now join all of them, right? So the y-intercept, that comes down and it goes through that. And as you can see, the shape there and the shape there is exactly the same. But important, I can see that you've joined all the points. All right, guys. Now, this is just to give an idea. Okay, Josh and Chris, let me rather satisfy you. They said, sir, we also said that. Thank you to you two for rectifying the answer, right? Let's have a look at the last question, what they ask. Determine the equation of the tangent to f when x is equal to minus 2. Right. What is a tangent? Next question. A tangent is a line that touches a circle or a curve at one point. So this tangent touches at x equals minus 2. Now, if you look at the graph, let's see if you can get that understanding. There is x minus 1, there's minus 2. So what they say is that is where the tangent should be. Right? Now, if you look at it, it's going to be something like that. Right? Guys, you need to get that understanding, not about what does this mean. Try to get understanding, what do I need to do? So, what is a tangent? Yes, a tangent is a line. So, to get the equation of a line, remember we need two things. We need a gradient and we need a point. So, what we can do here, immediately, we can say, the 1.8, right? How do we get the gradient? Let's reflect on that. To get the gradient, you will find f prime x. which we've calculated on 2 occasions. So f prime x is 2x squared, 3x squared plus 2x minus 5. Right? That is how to get the gradient of a tangent. So then you substitute the negative 2 in place of that. That means wherever I see x, I substitute negative 2 in there. And that will give you, therefore, 3. What does that mean? Your gradient is 3. Now from there, now remember there are two things, or 2 ways. Y minus y1 equals mx minus x1. Because a gradient or a tangent is a line. So what is the point that we have on this? Another point, right? So you need to find any other point. So if x is negative 2, right? So that means if we substitute negative 2 in there, our point, if you substitute negative 2 in there, our corresponding y value would be 9. Again, let's have a look at. You see there's negative 2. If we go up, can you see that corresponding y value is 9? So to find the equation of the tangent, we need a gradient. We've calculated that. And we need a point on the tangent. And there is our point. So if we just substitute that into the equation, we will have y minus 9. The gradient is 3. X minus minus 2. That is plus 2. And if we simplify that, it's going to give us 3x plus 6. And if minus 9 comes over, it becomes plus 9. So therefore, our tangent is y equals 3x plus 15. Right? Alright guys, I know they were saying, sir, I forgot about 1.7. Well, I did not forget about 1.7, Wenzel. I just wanted to keep that for last in order because I want us to have a look at the graph. Right? What does it say? For which value or values of f of x is fx increasing? Right? If it's increasing, what does that mean? Right? Increasing. Where do you see a positive slope? Now back to what is a positive slope? Right? This, guys, is a positive slope. Remember the right arm? That is a negative slope. Now where in the graph do I see that? I see that in the graph from this point. Let me just make that onwards. Can you see there? From that point onwards, can you see it's less? So how will we write that? Where x is less or equal than, what is that value? Negative 1, 7. Remember that is the x value over there. There we go. So on the left of that, the value decreases. Therefore, is where x is less or equal than negative 1, 7. Where do we also see that? We see it over here. And you see that? Positive slope. So if it's on the right of 1, so x is greater than equal than 1. If it asks you, where is it decreasing? It would have been between these 2 points. Are you with me? Between these two. So that is for increasing and that is for decreasing. Well, alright guys, as you can see, a mouthful. Hope I can go through the other 2 questions as well. But just to give you an idea where I wanted to give at least one type of question of each, up till the point of inflection, until a bit of interpretation, greater than, less than, blah, blah, blah. Right? So you can see, it is quite imperative, important, that as you work with the calculation, verify with your calculator if you have one to make sure you have that. I hope that was a good understanding. Let's have a look at another question. The next question deals with, what if they give you a graph? Right? Here they give you a graph. And this is the interpretation that I was referring to. It says there, the graph of fx equals ax cubed plus bx squared plus cx plus d is given. So we know that is the cubic graph there. Right? How do we know that? That's a cubic function. So they give you certain information. And they give you gx equals 6x minus 6. Where's that? Then we know it's a line graph. It's a linear function. Right? Then it says a is equal to minus 1 and 0, c is equal to 3 and 0. That's the x-intercepts. Also, that 0 and minus 6 is the y-intercept of the line graph. And then D and E are the points of intersection. So you see, we need to understand what they give you in terms of the wording. Read through it. Look at your sketch and try to understand. Now I know what it means. Now just go back to that previous sketch. If you can get some basic thinking in this. When they give you a graph, just look at this grade 12 very carefully. If you see the graph turn on the x-axis, you see at this point, the graph turn on the x-axis. Now let's have a look at what can you say or tell me about the x value. Let's look at the x-intercepts. What can you tell me? And that is something that you must try to understand. The graph, let me explain that again, has a turning point on the x-axis. What does that mean? Look at the x-intercepts. Then you will get maybe an understanding. Right? Let me give you an answer. Can you see that you will have a duplication of the x value? You understand that, guys? Write it down, get it into your head and say, okay, now I know. Right? If the graph turn on the x-axis, you will have the duplication of the x-intercept. Now with that bit of understanding, let's go to the next question. Then you can see what I mean. There, we have a turning point on the x-axis. Or should I say the x-axis, yes. What does that say? There will be a duplication of that x-intercept. Right? It's just for something that, okay, now I know for next time. Right? So what are the questions? Show that a is equal to 2, b is equal to minus 2, and c is equal to minus 6. Show that. Right? That shouldn't be a problem. Let's go see what is a, b, and c. A, b, and c is the numerical value in front of x cubed, of x squared, and x. Right? Those are the three values that we need to calculate or show. Right? How do we start with that? Right? Let's just give some 2.1. Let's see what do we have. To find that, or fx, we know the standard form is normally a equals x. Let's look at this graph again. What can we say about x minus 1? That's a duplication. So what is the factor of minus 1? Do you agree with me? It's x plus 1. Right? The same thing. Here is my other x-intercept. Right? That is 3 comes from the factor x minus 3. But remember, what did I say, guys? I said, if the turning point is on the x-axis, that x-intercept is a duplication. Are you with me? Try just to get that understanding for the future. Now, I need to go and find the a value. So how do we get a? We need to find any other value on the graph. So we use that. What other value do we have? 0 and minus 6. So that is the x value is 0 and the y value is minus 6. So if I need to go and substitute in there, we will have, that is negative 6 equals a. What is my x value? There is it. 0 plus 1 squared, and again 0 minus 3. Again, it's just now numbers. We can just work that out. Right? So 1 squared is 1, and that gives you minus 3. Right? Okay, let me rather show that step. It's a, 0 plus 1 is 1, and 1 squared is 1, and 0 minus 3 is negative 3. And that will give us, therefore, negative 6 equals negative 3a. Are you with me? 1 times negative 3 is negative 3, times a is negative 3a. And if we divide both sides by negative 3, we can see we're getting on the right track. A is equal to 2. Now you see there it says, show that a is equal to 2. We know it must be that. Now to get my other values, all that we have to do, we can just remove the brackets. a is 2. So we have x plus 1 squared, x minus 3. Just a bit of algebraic skills here. That means just remove the brackets. Right? So if we remove the brackets, square binomial, x squared plus 2x plus 1, right? And that's going to give me x minus 3. You agree with me? And then what do we do from there? We just need to multiply x with each one there and 2 with that. Right? So that will give us then 2x to the power 3 minus 2x squared minus 10x minus 6. Guys, I'm just, from there, you remove the bracket, right? You multiply this with that and 2 with that answer, or 2 with that, irrespective of how, but that is going to be your equation. So what does that mean? Let's go back there. Where is a? A is the value in front of x cubed. Happy. B is the value in front of x squared. Negative 2. You see? Happy? That is what they ask you here. And in C is in, obviously, what we have here is your numerical value there. And that is going to be negative 6. So can you see, guys, it's not so hard if you look in terms of how to get your answer. Let me just see if I can do another sum quickly. Then they ask you now, sorry, calculate the coordinates, right? Calculate the coordinates of the turning point B. Now, I'm not going to run through that fast because we know by now how to calculate the turning point of a turning point, right? How do we get turning points? Remember, we find the derivative. And because we have the equation that we've worked out, right? We have the equation there. We just need to find the derivative, right? So what is the derivative? Let me just quickly show there. We will have f prime x equals, the derivative is going to be 6x squared minus 4x minus 10. Remember, put the derivative equal to 0. And if we do that, then our x1 value is going to be 5 over 3. And our x2 value is going to be negative 1. Now, guys, I'm just going a bit fast, but remember the understanding. You need to put this equal to 0. You factorize. That are the two x values. How do I get my corresponding y values? I substitute that into the original equation and that. But because of where point B is, can you see point B is a positive x value, right? Which is this 5 over 3. So if you put 5 over 3 into the equation, original, you will get something that doesn't look so nice, minus 512 over 27. So that means your B would be 5 over 3. If you want to write it as decimals, that will also be accepted. And minus 512 over 27 is minus 18,96. Right? So make sure, guys, that when you look at and work with these things, that you have that understanding on how to work out this. Right? And then, let me just see this question. Hx is the vertical distance between fx and gx such that hx equals fx minus gx. Again, sir, what do you mean by that? Right? What does it mean? Right? Fx is given, there is fx. Gx is given, there we have gx. Now where they say hx is the difference between fx minus gx. Right? The difference between the two. Now the difference between the two, what is fx? Right? Let's see, what is fx? Remember, this is fx. 2x to the power of 3 minus 2x squared minus 10x, right? Minus 6, right? Minus, then what is gx? Gx is a line graph that is given as 6x minus 6. So that is just what they ask you, what they give you. They just say hx is the difference of fx and gx. So it's again some algebra. If we just simplify that, like terms, we're going to end up with 2x cubed minus 2x squared minus 16x. Because minus 10 and minus 6 gives you minus 16. Minus 6 and plus 6 cancel. Now let's go to word. Calculate x such that hx is a maximum where x is less than 0. Right? Where x is less than 0. Again, all right, sir, what does that mean? Right? Maximum, when you work with maxima and minima, what did you do? You've worked with the derivative. Right? You've worked with the derivative. So what is the derivative of that? Is that you're going to say the derivative is h prime x. Remember how we write derivative? So it's 6x squared minus 4x minus 16. We put the derivative equal to 0. And now we solve x. Now let's just have a look at these are my x values. X is minus 4 over 3 or x is equal to 2. Right? Or x is equal to 2. What does the question ask, guys? They say, where x is less than 0. X is less than 0. What does that mean? Less than 0 means which of the x values will be negative. And if you look at the 2, you will therefore say, where x is equal to negative 4 over 3. Right? Are you with me? I just have something. Yes, Wimby. I've seen some of them said, sir, let's just go back to that previous one. I fully just understand what you mean. Where they ask here, sorry guys, here, the C value, in actual fact, the question, right? I think the question in your book, is not where C, I think it is where D is equal to minus 6. Right? So that is a question that is in your book that they ask. But nevertheless, if they look at this, then your D value, it is negative 6. Right? Okay, if they had to ask for C, C would have been minus 10. Right? It's again just, okay, it's not to make an excuse that it's just a type of error there, but I agree with you. And again, thank you to these guys. I'm just saying, you are absolutely correct by saying, sir, we know the equation is ax cubed plus bx squared plus cx plus d. Right? So c is a numerical value in front of x, which we said in the PowerPoint, yes. And in this case, your c value is minus 10, absolutely perfect. And your d value is the numerical value without x. And in this case, then d would have been minus 6 and c would have been minus 10. All right, learners, it's just a pity because I would like to just to have a look at this question. I'm not going to do it because I know it's going to be a problem with time. This is the third question that I've mentioned, where as I said, can you see here they give you a derivative graph. So a derivative graph is like if you take a cubic function, remember what I said, if you have a cubic function and you find the derivative of that, what do you get? You get a quadratic function. Now do you understand why they say a derivative function is a parabola? Because x to the power of 2 is a parabola. So the third type of question that they can ask you is they give you a derivative graph and then they can ask you questions on that. And again, the type of question that they ask will work something similar as the previous one. Right? It's again about determine the equation of that, write down the coordinates of the turning point, the point of inflection. Can you see the same type of questions will come up? Right? Time is up, yes, and unfortunately, as much as I would like to, it's not doing that question, but I hope at least I'm glad that I could cover how to sketch, how to calculate your information, and especially how to plot. And then secondly, once they give you that information, yes, how can I do the graph interpretation? What do I need to look at? What are crucial points that I have to look at? And again, a crucial point is, if the graph turns on the x-axis, it means there's a duplication of that same mark. So you see, grade 12s, these are the small things. If we have that understanding, we should be able to ace our graphs. So from me, again, all of you, I am very thankful for your contribution. You know, all the work that you've said and working with me, giving me answers, and even showed me on some of the mistakes I made. Thank you very much for all that contribution. I hope the next session we will have just as enjoyable as this one. So from me, a very good afternoon.